Welcome back, mathematicians. Today's topic is on natural and whole numbers, properties of 1 and 0, and ordering and comparing numbers. This will be found on page 5 and 6 of your textbook. The natural numbers are the smallest numbers in our number system. They start at 1 and continue to infinity. These are also known as the counting numbers, and the symbol for natural numbers is an n. When we write it, the n has a double bar to start with, like that, n for natural numbers. We always use curly brackets to list the set. Dot, dot, dot means and so on to infinity. The next group of numbers is called the whole numbers. These are the natural numbers, but now a 0 has been included. So when we write the whole numbers, the symbol also includes a 0 at the foot, not next to, not the same size, but a little subscript. Once again, curly brackets, 0, 1, 2, and so on to infinity. The whole numbers are the natural numbers plus 0. That will give you the set of whole numbers. Let's look at the properties of 0. First of all, 0 and addition. 0 plus 5 equals 5. 391 plus 0 equals 391. Whether you add a number to 0 or 0 to a number, the number keeps its identity. Therefore, 0 is the identity element for addition. What happens when we multiply by 0? Well, 5 multiplied by 0 will give you 0. 0 multiplied by 2,341 will give you 0. So the product of any number and 0 is always 0. Let's look at 0 and division. We'll first look at ordinary division. 6 divided by 2 will give you 3, because 2 multiplied by 3 will give you 6. This is also called the inverse operation. If I have 15 divided by 3, the answer is 5, because 3 multiplied by 5 equals 15. Now let's add in a 0. So 0 divided by 13 equals 0, because 13 times what will give you 0. From this law here, we see that 13 times what will give you 0. Well, any number multiplied by 0 will give you 0. Let's look when we divide a whole number. So 6 divided by 0 equals what? Using the same principle as above, 0 multiplied by what will give you 6. Well, from this rule here, you know that 0 multiplied by anything has to give you 0. So this doesn't quite make sense. Division by 0 is not allowed. And if we are dividing something by 0, so 6 divided by 0, if we write it mathematically, is undefined. One way to remember it is 0 is underneath, under. So it is undefined. Not error message or anything else, but undefined. If you spoke to someone and you told them you got 0 out of 13 for your test, they're going to be quite upset with you because it'll mean you didn't study your work. But if you got 6 out of 0, if you went to your friends at break and said, I got 6 out of 0 from my test, well, they would think you're quite nuts because you can't get 6 out of 0. And that is one way of remembering which is the undefined result. Properties of 1 and multiplication. So if I have 6,279 and I multiply it by 1, my answer is going to be 6,279. If I have 1 multiplied by 1,003, my answer is going to be 1,003. Once again, the number retains its identity. So 1 is the identity element for multiplication. 1 and division. If I had 999 and I divided it by 1, the answer would be 999. It's just another way of saying 999 divided by 1. So that is just written like that. If I had 83,917,563 and I divided it by 1, my answer would be 83,917,563. Once again, you can see the number has maintained its identity. So 1 is the identity element for division. How would I get a quotient of 1? So for example, 52 divided by what will give me 1? Well, 52 divided by 52 equals 1. 4,000 divided by what will give me 1? 4,000 divided by 4,000. So therefore, any number divided by itself is equal to 1. Right, when we order and compare whole numbers, you're expected to know how to group numbers in threes from the back because each group of 3 has a group name. The ones, the thousands, the millions, the billions. And each of these have hundreds, tens, and units. So if we have a look at our number, one four two zero 597, in order to read that number, what we do is we count in threes from the back. 1, 2, 3, 1, 2, 3, and now we have 14, 208, 597. Then we've got to remember the smallest group are the ones. And in the ones we have hundreds, tens, and units. The next group are the thousands. And in the thousands we also have hundreds, tens, and units. The next biggest group are the millions with hundreds, tens, and thousands. And the last group we're dealing with are the billions. It's important to remember that we're not going to be using the unit, but instead we would use the name thousand. Million instead of the name unit. No units, but billions. What we then do is we write the number from back to front. 7, 9, 5, 8, 0, 2, 4, 1. I choose to do it this way to ensure that I don't leave any spaces or put it in the wrong column. So, in order to read the number, all we're going to do is look at each group at a time. Over here, I have 14 million. Next group, I read the number 208, and they are the thousands. And the last one is 597. So you see, if you group your numbers in threes, you can read a number of any magnitude. If I write it out, or if I say it, it is 14,208,597. I finished explaining the notes to you, so now I'm going to move on to the worked example on page 8. First of all, we've got to understand what descending means. So we have to arrange these numbers in descending order, which means from biggest to smallest. Descending begins with a D, so these numbers are going down in order of magnitude. The other word that is used is the numbers that go from smallest to biggest, and these are known as ascending numbers. If we go up, the first thing we look to see how many digits we have. And all of these numbers are 2 million because there are 7 digits. So 2,579,000. So I'm just observing to see how many 100,000s there are. And if I get to these two, we will see that we've got 600,000 here, which is bigger than 579,000. If I look at this number, the only difference is in the unit. This has 1 unit more than that number. So clearly this is the biggest number. So the first number in our sequence or in our list is going to be 2,600,001. Clearly the next number is the next biggest. Now I go back to my numbers and I have a look at what follows the 579,000. Well, I have a 3, 300, 300, 600. Well, 600 is definitely bigger than 300, so this would be the next number in my sequence. 2,579,643. Now I look at my remaining numbers and I look at the next digit. This is 60 and that is 40. 6 is greater than 4, so this is the next number in my sequence. And then the last number is 2,579,346. If we had to arrange in ascending order, we would then just go from the smallest number and we would arrange them in that order. That would be ascending order from the smallest number to the biggest number. Now you can pause your video and you can test your understanding. That is on page 8. That's all for today. Thank you.